All right. I hope it's recording. Yeah, good morning, year 9 students and whoever is watching this video. Uh, I'm doing this video just to teach a lesson on set theory, and I'm going to be posting the objectives right away, so you get to see the objectives. Basically, we have very little time to finish this work. I hope I'm going to post the objectives and you're going to be able to see them. Okay, so there we go. Now, so the objectives, these are the objectives of the lesson. So the first objective is to define terms like subset. I hope you can see well. Define terms like subset, proper subset, use their symbols. They have symbols, subset and proper subset. Have symbols I'm going to be showing you shortly. For example, if I take a subset basically you write a subset. If a set A is a subset of another set B, you probably write it like this. Okay, well it's not like that actually, but it's A, then you have this real sign, is a subset of B. All right, and what is a subset? A subset basically is, for example, let's say I take the set of let me see, a set A, for example, 1 to 5, and set B is also 1 to 5, right? You understand? That means set A is a subset of B because the elements of A are in B, they're all in B, all right? Now, there is a difference between subset and proper subset. Let's take, for example, the case of year 9 students. Let's say year 9 students is a set A. We are like 14 or 13 of us in year 9. Now, let's talk about the set of year 9 students that play basketball. You realize that all the students that play basketball in year 9, or all the students in year 9 class, are not the students that play basketball in year 9. So there are a few exceptions of students that play basketball in year 9. So for example, the set of students that play basketball is, for example, Carl, Jadi, Archie, Greg, Ryan Camden, I think Hannah too, and then the rest of the class doesn't play basketball, right? If I missed your name, sorry. All right. Therefore, the set A of students that play basketball is a proper subset of the set B of year 9 students. Now, basically, what does this mean? This simply means that if you have elements in one set and all those elements are in another set, but in the other set, there are other elements that are not in the previous set, it means that the set is a subset of a proper subset of the other. Okay, I'm going to use an example later on. Now, the next thing is to list universal set. Okay, we can have universal sets, for example, like numbers from 1 to 10. A universal set is a general set, like universal. It's a general set from 1 to 10, for example. And okay, let's just get into this. Okay, let's just get into this and then we continue. All right, so I have to stop the share from here and I share from my phone. Okay. Okay, so whiteboard. Good, I think we are online now. So I want to take an example of, let's take an example of set A. Set A is made up of A, B, C. And set B is made up of A, B, C. I'm going to create a new whiteboard. Let's say set C is A, set D is B. Oh, sorry, that was supposed to be B. And set E, for example, is C. Then we have another set F, which is this, or this. Set F, I'm sure everybody knows that is an empty set. Now, I want us to use all these definitions. Let's start from the previous one. The previous one we saw. I thought I created a new whiteboard. Okay. What's happening? View all the whiteboards. There are two, but no one is appearing. Fine. You know what? Let me just create another one. Originally, I said the first set was a set A, which is made up of A, B, C. And a set B, which is also made up of A, B, C. Now, I want you to look at these sets properly. I said a subset. A subset exists, for example, between A and B. A is a subset of B, or B is a subset of A, because all the elements in A are in B, right? And so you write this like this, subset. This is how you write it. So you say A is a subset of B, because ABC is in A and ABC is in B. But now look at the case of the other sets, like let's look at the other case. Right, there's one of my things here. Look at C, D, E, F. All the sets now are proper subset of all the sets are proper subset. All the sets are proper subsets of A and B, because let's say A is a universal set. A is a universal set because it contains all the elements we're talking about. All right. Now, all the sets are proper subsets of A. So basically, how do we write this? How do we write this? We are going to write A. So C is a proper subset of A. D is a proper subset of A. E is a proper subset of A. There is this last set, which is F, and that set is an empty set. What does this set represent in our studies? This set is called an empty set. And it is important to note that an empty set is a subset of every set. Like technically, there's an empty set in every set. You understand? So you say F definitely is a proper subset of F is a proper subset of A. Because an empty set is a proper subset of every set. You understand? Good. So since I said this empty set is a subset of every set, that's how we're going to write it. Okay? Now I want to look at the next objective, which is to list elements of a universal set. I want to talk about universal set, and then okay, let's talk about universal set. Now, what is a universal set? They define a universal set as a set consisting of, all the elements that are being talked about in your problem. Okay, I'll read, for example, what is set here. The set containing all objects or elements, and of which all other sets are subsets. It means that if you have a specific problem, for example, in a question, and there are sets that are formed from a bigger set, for example, I'll tell you list prime numbers up to 20. List prime numbers up to 20 as your universal set. You can either write this symbol or this symbol, then you start listing 2, 3, 5, 7, 11, 13. After 13 is 17, and then 19, full stop. That's your universal set, right? Okay, I want to list this on a new thing. And let me list this thing so that it's clear. So our universal set equals to 2, 3, 5, 7, 11, 13, 17, and 19. Remember that a prime number is a number with only two factors. It's different from composite numbers that have more than two factors. Now, so you check out this. This is our universal set. Now, from this our universal set, we can create subsets. Okay? We can create proper subsets. For example, I see that we can create a set of odd numbers from the set. We can create a set of even numbers from the set. What else can we create from the set? Basically, this is 19 at the end, eh? Basically, that's the type of sets we can create, unless we just write numbers at random and say these are a set. This set belongs, for example, I say 3, 5, 11, 7, without any really, without an explanation, say that's a set, and then it forms a proper subset. Okay, so basically, that is it. So we have this as our proper subset. Now, there is this other term. It's another objective that I wanted us to talk about. Define and state the complement of a set on the universal set. Now, the next thing we're looking at, because we're going fast, because I have a class after this, complement of a set. For example, A, if you have a set complement of a set A, you can write it as A complement or A prime. If you see this anywhere, that means that's a complement of a set. Now, I want you to think about, what do you think a complement of a set is? Like, what would be the complement of a set? All right. Okay. Now let me take, for example, I want us to consider this example. I explain universal set, mix it together with complement, and then that will be it, right? So basically, I am going to create a new whiteboard. Now, let's take a set of vowels. A set of vowels. Set A is set of vowels. Set of vowels. Okay, so it means A, the elements of A are A, E, E, O, U. All right, so you can say, just to remind you, A is an element of A. E is an element of what? A. And then you can also write H is not an element of A. I hope that that notation is okay with you. All right, so you get to understand these things, right? So you now know how to write something is not an element of another thing. Okay, so basically that's it. Okay, I want to write it again so you understand. Of course, Z is not is like that, an element of A, because Z does not belong to vowels, right? But now if you're using Y, it can be confusing, because depending on the language, Y is not an element of A in English, but Y is an element of A in French. Okay, so you need to understand the language you're dealing with. Okay, Y. Okay, let's talk about. So this is our set. This is our universal set. Our universal set is A. That. So I want to cancel this A and instead write universal set. Epsilon. Universal set. So that's our universal set, A, E, I, okay? Okay, now let me create a set A. Set A is made up of O and U, okay? Set A is made up of, okay, let me make it a little funny, because I know you guys are gonna laugh after this part. Set A is U and I. Get it? You and I, right? Like you and me, you and I. That's supposed to be funny. In case you're not laughing and you don't have a sense of humor. Good. So set A is you and I, right? You and I. Now, my question is, what if you have clearly defined the set A? But what if you want to write the complement of set A? You're going to write the complement of set A. Okay, let's repeat set A here. It is you and I. What if you want to find the complement of A or the complement of A? The complement of A are simply the elements that are in the universal set but are not in A. So if I remember very well, the universal set have A, E, O, U. But I and you are in A. So what I start in A is this, this, and this. So this is called A complement. A complement because they are not in A, and that's the meaning of A complement. They can ask you a question like this. So what is the cardinality of A, and what is the cardinality of A complement? The cardinality simply means number of elements, and cardinality. I'll write it and erase it. Cardinality. I'm writing with my fingers, so it's not easy. Cardinality means number of elements, like that. Okay, number of elements. So I'm going to wipe it. We remember that set A was you and I. So basically, there are how many elements there? There are 2. And then the cardinality of A prime is the cardinality of the universal set minus the cardinality of A. Cardinality of the universal set minus cardinality of A, which is 5 minus 2 gives 3. And basically, we have done that, all right? Now, I want to ask you a very technical question that most of you will be finding very funny, but I love it. What is this? This is called universal set. But what is the prime of the universal set? Can you check it? Just pause and check. If you've okay on pause now, you'll notice that if you list all the elements of the universal set, I want to find the elements that are not in the universal set. The universal set is a set we're considering. So if there is an element that's not in the universal set, then we don't know it, or in case it doesn't exist, it is an empty set, right? Now I want to ask you a question. What is the cardinality of an empty set? Oh, sorry. I was talking about complements. Sorry, I'll talk about complements. What is the complement of a universal set? It is an empty set. Because if there's something that's not in the universal set, it should be an empty set. Okay. Now, what is the cardinality of an empty set? It is the universal set. What is the complement? I am saying complement and confusing with cardinality. Now, this term, I'm sure you understand what I mean. But please, this thing is complement. When you see the prime or the C, it's complement. So if you get this information, then you're good to go. And I'm going to set questions on quizzes, and you are going to answer them. Okay, you're going to answer them. Okay, and yeah, basically that would be it. You answer those quizzes, and I expect nobody to get less than 90%. Okay, I'm going to stop the video here. It was nice doing business with all of you. Though you didn't do my homework, I'm not quite pleased with the fact that I didn't do my homework. And I am hoping that next time you do my homework. All right. I have to leave the meeting and I have to stop the recording.